Hi, so my goal is to create very short videos that briefly but also precisely explain math concepts. And for this video, I will be demonstrating how to solve derivatives with quotients. But I do want to show you the sheet first. In each video, I will be showing this sheet that I have here to explain the how behind how I am taking the derivative of a problem and how I'm approaching the problem so you understand the logic behind it. But I won't explain all of them. I'll only explain the ones that actually apply to the problems I'll be demonstrating in the video. So here, let's go over the quotient real quick because I will be going over two quotient problems. So for quotients, g over x, if you take the derivative of g over x over h of x, then you want to take the derivative of g of x times h of x minus the derivative of h of x times g of x over h of x squared. Now let me briefly tell you what all that means. Basically, what you're doing is you're taking the derivative of the numerator, then you multiply it by the denominator, and then you subtract it. Then you take the derivative of the denominator, and then multiply it by the numerator, and then divide that by h of x squared. So g of x and h of x, they just represent functions. They represent expressions. Now, you actually typically want to use the quotient rule when you are doing problems that have a complicated denominator, something like 6x plus 5, something that you can't take apart, right? So, but if you had just one value in the denominator, now that's something you could take apart if your numerator had also multiple different values. Right, you can individually take them apart and they'd all have the same denominator. Like, for example, there was a 7, or if there was just an x under the denominator and there was like 4x plus 5 in the numerator, you can take those two apart, just have 4x over that, let's say 7, and then you'd have that plus 5 over 7. So you can take them individually apart and then you can evaluate them so you can cancel the denominator and therefore just have a whole expression simplified, which is easier to take the derivative of. Okay, so you probably thought I was going nowhere about how for some quotients, if there is only one value in the denominator, we have to take a different approach. But no, actually we do have a problem like this, so I wanted to sort that out first. But okay, so clearly we can see the first thing you want to do, let me say this, the first thing that you want to do when you're dealing with any derivative problem is to identify what kind of approach you're going to use first. What kind of problem are you dealing with? Right, so clearly we're dealing with quotient rules, and that's what this video is about. So we already know that we're going to have to take that we likely have to take that approach. But because we only have one value in this problem, we can actually split this up. So 3x to the third power and put it over x plus 4x squared over x minus 9. And instead of writing this as the square root of x, we'll write this as 9x times 1 over 2, because it'll be better in the long run when we take the derivative of it later. And remember that 9x, or really x to the power of 1 over 2, is the same as the square root of x. Okay, so now that we got that out the way, we can evaluate further. Because we have the same base, right? X is, my bad, I forgot to write the x over there. Okay, so right, we're dealing with the same bases. We have x here, x there, so really we just have to subtract the powers, right? So alright, 3x squared, because 3 minus 1 is 2, plus 4x, because 2 minus 1 is 1, minus 9, And the trick here, when we're dealing with fractions, we may hesitate to do our normal adding and subtracting because it's a little different when it comes to a fraction and an integer, right? Because we have 1 over 2 minus 1. So the trick is looking at the denominator, the trick is looking at the fraction and multiplying the denominator with that integer, right? And knowing that both of these then are fractions of the same denominator. Okay, but now just ignoring 2, looking at the numerator, I'll have 1 minus 2. But remember that this is how I'm looking at it, that it's all over 2. So once I figure out, okay, what's 1 minus 2? That's negative 1. So then I know that this answer is going to evaluate to negative 1 over 2. So that means that that means that this is all going to evaluate to negative, or minus 9x to the power of negative 1 over 2. Okay, so now we can start taking the derivative of this function. So 3 times 2 is 6. 2 minus 1 is 1. Plus 4 times 1 is 4. X. 1 minus 1 is 0. And anything to the 0 power is just 1. So we can just leave it as 4 because 1 times 4 is 4. Okay. Minus 9 times negative 1 over 2. That's going to be negative 9 over 2, but we don't want to write 2 minuses. Well, 2 minuses make a positive, so we're just going to rewrite this as just a positive. So we'll just leave 9 over 2x. Okay. And we do the same trick that I taught you earlier, which is we look at the 2. We know that we're going to subtract from 1, right? So we just think of this as we must put 2 there, so we just have 2 over negative 1 minus 2, pretty much, which is negative 3 over 2. Right, because it's like we're multiplying 2 over 2, which will give us negative 1 minus 2 over 2. Just want you to see that. So sometimes your teacher would like to see evaluated a different way, at least this part really, because another step that you'll take down the road is you'd want to solve for this. And when you solve for this, this here will be getting in the way. You don't really want that in the picture. So another way you can write the solution is 6x plus 4 plus 9 over the cube root. Oh, I'm sorry, I forgot the 2. 9 over 2 times the cube root of x. And this is in this form, it makes it easier to solve for it. So, but they really both mean the same thing. So I think your teacher, it depends on the teacher, but both of these solutions are correct. Alright, so let's move on to the next one. So we have 4x plus 1 over 1x squared minus 5. Okay, so I put the 1 there just so you remember that there is a 1 there, but I'm going to erase it. But remember that because on the paper, that's going to be omitted, but it's there. Okay, so we're dealing with the quotient. But the denominator, it's a bit complicated. This isn't something we could take apart. We can't do 4x over x squared minus 5 plus 1 over x squared minus 5. We can't do that. That's not allowed. So instead, we're going to do the usual approach. This 4x, right? Okay, so let's look at this 4x, right? So when we took the derivative of 4x earlier, we got 4. And that's just the thing. When you take the derivative of a number next to an x, and it's to the power of 1, it's always going to just be that number, and you're dropping the x. So I'm not going to bother explaining how I would usually do. I'm just going to write 4, because that's also like the trick. With a single glance, I see that there's an x to the power of 1, so the derivative is 4. Now, same thing with a constant. If you take the derivative of a constant, it's always 0. So as soon as I see a constant, it's already automatically 0. So this is basically plus 0, but I'm not going to write all of that out. We already know that. So I'm just going to multiply the denominator, as we should. And now I'm going to take the derivative of the denominator, right? So we have 2 times 1 here, which is 2, times x, and 2 minus 1 is 1, so that's just going to be 2 times x to the power of 1, but I will not write the 1 down, it's implied. And then if I take a constant, if I take the derivative of this constant, -5, that will also be 0, so I'm not going to bother writing that down. And now I will multiply the numerator with 2x. So here we have 4x plus 1. Great. And then we put that over x squared minus 5. Sorry about the bad handwriting throughout the video, I can't help it. So we can simplify this, the numerator, even further. I'm sorry, I forgot to square that. Even further, right? So let's distribute the 4, let's distribute the 2x, and later we'll distribute the negative. Okay, so 4 times x squared is 4x squared. 4 times -5 b minus 20 minus 2x times 4x, that's 8x squared, and 2x times 1 is positive 2x. Okay, and then as we distribute the negative, we'll have a, let's just rewrite this down here, 4x squared minus 20. And we'll have a negative 8x squared here, and then negative 2x. Okay, and we know that we can combine like terms here because we have both terms that have x squares in them, right? So negative 8 with 4, okay, that's basically 4 minus 8, which is like 8 minus 4, which is 4, right? But we just have to bring down that negative. So negative 4x squared minus 2x minus 20 over, don't forget the denominator, x squared minus 5 squared. And that's your final answer.